good day to Dr. Nobaya. My name is Yuvanesh Ramu. So today our group will be presenting frequency shift keying FSK and binary phase shift keying BPSK. As we can see, our group consists of 5 people as listed in this slide. And moving on to the introduction of FSK. FSK is known as frequency shift keying, a type of frequency modulation that is most basic and widely used modulation technique. It is used everywhere. By alternating between 2 frequencies, an oscillator transmits data. There is a traditional frequency demodulator inside the receiver. As we know, in a basic communication system, we have the transmitter, and then in the middle, we have certain processes, and at the end of the communication system, we have the receiver. So the transmitter transmits data, and then it goes through the modulator, and the processes begin, and later on, after certain processes, it reaches the demodulator, which is at the receiver. A shaping circuit that returns the pulses to their original form comes next. FSK modulates waveforms by using 2 carrier signals, for example, carrier signal A and carrier signal B, which can we see in this diagram with the trigonometric representation of cos 2 pi ft. The representation of FSK modulates signal in terms of 2 distinct frequencies is the cause of this. The terms space frequency and Mach frequencies refer to the frequencies. Before this, I mentioned that there is frequency A and frequency B. So these frequencies are given the terms space frequency and Mach frequency. Now I will hand it over to the next person in the next slide. Thank you.
Hi, my name is Nik Amirul Azam bin Nik Mazlan with the metric number B02210016. Today I will present about the introduction and the objective of this assignment. First, I will introduce the BPSK, which is the binary phase shift keying. In this digital modulation scheme used in the telecommunication and the data communication system. This is a type of phase keying modulation where the phase of the carrier signal is modified to present a digital data. BPSK is also particularly well suited for the communication system that requires the simplicity and efficiency in handling of binary data. In BPSK, the carrier signal phase is shifted by 100 degrees, or in radian is pi. Typically, one phase represent a binary of 1, and also the opposite phase represent a binary of 0. This modulation technique is commonly employed in various communication systems, including radio communication system, satellite communication system, and also the wire communication system. The simplicity of BPSK make it interactive choice for applications where bandwidth deficiency is not a critical concern. It is often used in situations where the available bandwidth is limited and reboot the communication in ensure, such as wireless communication channels, prone to fading and interference. Next is about the objective of this assignment. Okay, first is to explain the principle and properties of FSK and also BPSK modulation technique. And the second is to develop and simulate a BPSK and also FSK communication system by using the MATLAB application.
Hi, I am Muhammad Farhan bin Ahmad Syukur, metric number B0222102227. In this video, I will explain about the coding that we use for binary FSK with and without noise, and also BPSK. The difference between binary FSK with and without noise is in binary FSK without noise, the transmission occurs without interference, and the receiver can easily distinguish between the 2 frequencies representing the binary values, typically 0 and 1. On the other hand, in binary FSK with noise, the presence of noise can distort the signal during transmission. This interference can make it challenging for the receiver to accurately interpret the transmitted binary values. Next, let's go to the coding for binary FSK without noise. The first part is to initialize the binary information sequence, set the bit period, and display the binary information at the transmitter. The second part, the coding continues with the part that performs binary FSK modulation by generating sinusoidal waveform at different carrier frequencies based on the binary information sequence. Then, binary FSK modulation part. There are several things that we can point out in this part, such as initialization part, modulating loop, and plotting waveform. This part of the code performs binary FSK modulation by generating sinusoidal waveform at different carrier frequency based on the binary information sequence. Later, the binary FSK demodulation part. There are several categories involved in this coding part, such as initialization, demodulation loop, carrier signal, signal multiplication, integration round, integrated value, logic level check, store, and display demodulated information. And the last part is to generate a visual representation of the received information as a digital signal after binary FSK demodulation, with each bit period represented by a sequence of ones or zeros in the digital signal. For your information, modulation is the process of encoding information onto a carrier signal for transmission. However, demodulation is the process of extracting the original information signal from the modulated carrier signal at the receiver. After that, we run the coding and the output waveform obtained as shown on the slides. As we can see, the binary sequence 0 shows low frequency and binary sequence 1 shows high frequency in the waveform. Later, we also do the coding part for the binary FSK with noise. The difference between binary FSK with noise and binary FSK without noise lies only in noise command that we add after plotting waveform command in modulation part in binary FSK without noise. The output waveform that we got is just same with the other one, but just with the noise waveform. Okay, let's start with the block diagram for binary FSK that we generate using Simulink in MATLAB. The first step is we go to the library part and click source and add two sine wave block. These two block indicates binary sequence of 0 and 1. After that, we add switch block and set the threshold to 0.1. Connect both sine wave to the switch. Then, we go to the source again and add pulse generator block and connect it with the switch. Later, we add a multiplexer to combine multiple input signals into a single output signal and connect the pulse generator and the switch to it. And lastly, we add the oscilloscope block to get the output waveform as shown on the slide.
Hi, my name is Siva Yogan. Today I'm going to explain about the BPSK coding that we have done. This is the carrier frequency and then the sampling frequency, which is 2 and 20, and then the number of cycles is 1, and then the time duration is equals to number of cycles divided by FC, which is 1 over 2, and then the time vector is a ratio, and then it's 0 per 1, and then XC value we set as cos pi t, and then amplitude of the carrier signal we have set it 1, and then the EB value, the noise ratio, and the noise variance as well. And then bit stream, we need to indicate the data to store in the bit stream, and then the carrier signal as well. We must indicate it as we are going to do BPSK modulated carrier signal, and then we need to create a simple logic coding which is included if else statement, and then end it, and then we need to do it. We need to modulate it. We need to subtract some value from the modulated signal, which is negative 0.5, and then times with 2. So we include this type of coding, and then we need to indicate the MATLAB as BPSK signal is equals to carrier signal times by bit. And then after this coding, we must, in this entire coding is about to plot the signal in the MATLAB. As you can see here, this is our output, this is our digital signal, and then carrier signal. After it modulates, it will become a BPSK modulated signal. Thank you. Okay, now I'm going to present about the BPSK Simulink we have done in this assignment. This is a random integer. It will show us 1 or 0. It will be giving us a random signal, and then this is the BPSK modulation. It will modulate into include its carrier signal, and then this is the AWGN. AWGN is basically a noise giving block, and then this is a demodulation baseband, and then we can see the output over here, and then this is the this is basically a modulation it will include a carrier signal. This too is a carrier signal included. It will show indicating as that this is a sine wave and then this is a cos wave. Cos wave means it's one it's 180 angle lag from a sine wave, and then this is a real and imaginary divider. The real value will be times product with sine wave, and then the imaginary value will be product with the cos wave, and then these both will be added, and then it will be giving output. Now we run the program. This is a constellation diagram. We can see here, we can see noise over here, and then this is the output. As we can see here, we can see the input and the output is same, even though it's between modulated and inside AWGN and then demodulated. This is the BPSK modulation diagram output. As we can see here, if the data shows 0, the signal is not modulated. If the data shows 1, will be modulated according to the signal, the carrier signal we have give, which is, if the signal is give 1, the wave will be started from the 180 degree.
Hi, I'm Yuniswaran Alaki Kesavan, metric number B0222100053. In this video, I'm going to explain about the comparison between FSK and BPSK, which we get from the project and the waveform we get from the project. There are 4 main differences, which are modulation technique, spectral efficiency, bandwidth, and noise immunity. The first is modulation technique. In FSK, the digital data is represented by different frequencies. A binary 0 might be represented by one frequency and a binary 1 by another. The carrier frequency is shifted between these two frequencies to transmit the information. Meanwhile, in BPSK, the digital data is represented by different phase of the carrier signal. Typically, a binary 0 might be represented by a 0 degree phase and a binary 1 by a 180 degree phase shift. Next is spectral efficiency. For the spectral efficiency, FSK typically requires more bandwidth compared to BPSK for same data rate because different frequencies are used to represent different bits. But BPSK tends to have better spectral efficiency since it only requires two distinct phase states. Third is bandwidth. FSK requires a wider bandwidth due to the need for multiple frequency components. BPSK requires a narrower bandwidth compared to FSK. Last is noise immunity. FSK is more robust in the presence of noise because the demodulation process is less affected by amplitude variation. While BPSK is sensitive to phase changes, it can still perform well in certain noise conditions.
As in conclusion, the present works provide a thorough investigation and comparison of binary phase shift key and frequency shift key, two well-known modulation techniques in digital communication system. In order to understand the performance characteristic of this modulation scheme, the study involves putting them into practice and observing them. The BPSK modulation system was put into a practice, demonstrating how well it works, convey binary data by alerting the carrier signal phase. The report indicates that BPSK with the straightforward phase encoding techniques displays robustness against specific form of noise and phase distortion.